Hello, everyone. Thanks for your patience. My name is Amin. I don't have the thing here. So, okay, good. I'm a PhD student in computer science at University of Maine, and I hope I'm not the only person who talks about privacy, but doesn't know what exactly privacy means. And it is okay because privacy is a complex concept. I spent my entire master's in philosophy learning about theories of privacy, and I'm still not sure what privacy means. It's like other complex concepts which are interdisciplinary. They demand knowledge from different disciplines, from law, psychology, philosophy, ethics. And we added new technologies to this concept, so we have to take care of privacy from different perspectives. Here, even regulations do not help engineers to solve the privacy problems, because regulations tell you what you need to do, but they don't tell you how to do it, how to implement the privacy regulations in a system. And new privacy paradigms like privacy by design encourage you to be proactive, encourage the companies to be proactive with respect to privacy. But in order to be proactive with respect to privacy protection, you need to know in the first place what privacy is. And for these reasons, the solutions to privacy concerns are most of the time just ad hoc solutions or add-on to the existing system, which doesn't exactly fit in. The European Union Agency for Cybersecurity concluded its report about privacy protection with this demand that we need to improve system developers' knowledge about privacy. That's the only solution, because engineers know how to implement the system, but they don't know how to include privacy in the system. So I formulated a privacy paradigm that entails some theories of privacy, so that engineers can internalize the meaning of privacy and incorporate theories of privacy in their design and development. And my definition of privacy is privacy demands consistency of informational behaviors of a system with the reasonable expectations of the users. And I'm instantiating my privacy paradigm as the PRIPA. So privacy paradigms are an instantiation of paradigms with example of scientific paradigms. And they have three elements: theories, methods, and techniques. The theory is about users' expectations that they form their interaction with the environment. And the way that people collectively interact with the environment, they form the norms of that environment. And the norms, once again, they form the expectations of the user within that environment. So with this theory, we know we can make it easier to predict how people would behave in a system. And so we have this PRIPA's privacy engineering life cycle that incorporates this definition of privacy within the privacy engineering life cycle. We start with the requirements engineering. We extract people's users' expectations. We analyze those expectations versus the norms, see if there are any conflicts between those expectations and the system and the business model. We try to resolve those expectations or to document those expectations in the requirements phase, and then we model those expectations for the system designers and developers. They have to take care of these expectations with privacy by design approach, privacy enhancing technologies, and other existing techniques in order to make sure those expectations are met in the system. And at the end, we run a privacy review or verification. And if there is any conflicts, we have to repeat this. Thank you so much.
All right, thank you. Can our next speaker come up? That would be Conor.
Great, thank you. Hi, everyone. My name is Conor Gilsenan. I am starting my PhD program at Berkeley this fall. And today I'm here to talk about an open source project I created with a good friend of mine last year to help average internet users enable two-factor on their accounts. So one of the problem, two-factor adoption rates across the industry are incredibly low. And there are many problems for this, and I argue that one of the contributing problems is that many sites do a poor job notifying users that two-factor is available and encouraging them to enable it in the first place. Typically, users will have to locate the security menu, and this workflow could be different for every single website. There are some third-party resources available to help users with this problem. One of them is twofactorauth.org, which is a community-maintained database of websites that support two-factor or don't support two-factor, and also contains links to the documentation for how to get started. Another resource is turnon2fa.com, which really handholds users to enabling 2FA by providing step-by-step screenshots. And while both of these resources are great, the downside is that users need to be consistently proactive in using these resources as they go about creating new accounts. So this is where I propose 2FA Notifier, which is a browser extension that works in Chrome and Firefox, and it notifies users anytime they visit a website that supports two-factor. And when the notification is clicked, it will bring the user directly to the documentation for that service that helps them understand how to get started with their account. And one of the challenges is that the extension is designed with privacy in mind, and there are no analytics that are collected. So other than knowing how many users are utilizing the extension right now, there are a couple hundred, which is great for a small open source project, but I really want to get this into the lab to start to explore some questions in a more controlled environment to understand how effective this might be in helping users enable two-factor. Some of the things to look at are the actual frequency of notifications. We heard some good talks today about habitualization and alert fatigue. So understanding how frequently we can let users know as they visit websites before it becomes counterproductive and blending into the noise of other notifications. In addition, I'd like to look at the wording of the notification to help users enable two-factor. And another thing to look at would be whether it makes more sense to link to the documentation for each individual service or link directly to the site where they can start to take action to enable two-factor. I think that is going to vary on a site-by-site basis depending on the user experience that's offered. I'd really like to test this on larger populations as well, in addition to just controlled lab environments. And an ideal way to do that, I think, would be to partner with browsers to run an experiment in canary or nightly builds where users are expecting experimental functionality. One of the key advantages of that would be avoiding the necessary step of installing the browser extension in the first place as it exists today. In addition, it would be interesting to integrate some additional information into the extension so we could offer more contextual examples in the notification text. By way of example, Yubico has a wizard that asks plain English questions to help identify which of their products might work for a given user. And I think we can do research to identify plain English questions that users can answer, and depending on those answers, we can recommend a specific two-factor method that might work best for them. If we bundle this into two-factor, not only can we tell them two-factor is available, but a specific method that might work best for them is or is not available as well. So if you're interested, 2FANotifier.org is the website. Feel free to try the extension. And I would love to hear feedback and talk to you afterwards as well. Thanks for your time.
Well, it's very refreshing that someone wants to get stuff into the lab instead of out of the world.
Ah, a login screen. The all too familiar login screen. We open it up, enter our login details, and we hit the login button. Boom. Your login attempt is rejected. And this, even though that you know your password, you tried entering it, but you made a small typo, and you were rejected completely. You rip your hair out and have to do it all over again. But what if this was okay? So that for you, as a legitimate user, when you enter your password, you do a small typo, that's okay. But that we somehow could distinguish an adversary, someone trying to log into your account and require them to enter the exact correct password. To do this, we need to add an additional factor into the login. And what I've looked at is using typing of the password itself. So it's based on the assumption that typing is unique. So that similarly to handwriting, if you look at some written handwriting, you can often recognize who that person is. So similarly, there's characteristics in typing behavior that can be used for verifying user identity. And this is referred to as keystroke dynamics, and there's plenty of work on how this kind of recognition can be done. But what if we apply it to password typos? So I started off by conducting a small study. First, I wanted to see what kind of errors do people do when they're rejected from logging in. Are the characters just a single character off, or are they typing in something completely different? I also wanted to see how well can I recognize legitimate users, and how well can I tell that it's a bad guy logging in. So I created a small study website. I had participants enter email addresses, passwords, repeatedly over a course of 2 weeks. And while doing this, I recorded what password they attempted to log in with and the keystrokes. So the timing information when they pressed the keys and when they released the keys. And all of this was on mobile smartphone devices. And what I found is that small typos indeed are common. Of all the rejected login attempts, almost 70% of them were off by just a single character. As for recognizing users, the good guys, and recognizing the bad guys, the approach I tried was looking at keystroke latencies, so the time between keystrokes when entering the password. So let's say we're logging in with myduck123. That's the time in milliseconds between these keystrokes. And in a presentation earlier today on keystroke dynamics, this was referred to as the flight time. So I created this mean login attempt for each user, and then I compared a new login attempt to this one. I summed up the differences, the absolute distance, and then I required the sum of this to be below a certain threshold. And if it's small enough, I deem the user to be the legitimate user. Did this work? Nah, it didn't work too well. It was pretty terrible at recognizing legitimate users and pretty good at letting adversaries through. But there were some patterns I observed while analyzing the data. I found that the overall rhythm when logging in was pretty consistent for most users. And when it came to special characters and numbers, there was often a latency peak, which also was quite consistent. And in the beginning of words. So let's say I have my duck. So before the D in duck, there was a small pause. So suggesting that people think of the passwords as words and then enter them in bursts, and this was recognizable. So the result from this is that small typos indeed are common for rejected login attempts. The model I chose was terrible. Don't use it. There's others. But I found some patterns that could be interesting, and there seems to be stuff to recognize in this. So overall, I think that small typos should be allowed, and we should look into this a bit more and then see what else we could use for this, and leading to fewer rejected logins and better usability for users. And that was a summary of the findings from my bachelor's thesis, Improving Usability of Password Authentication Using Keystroke Dynamics. I'm Walter Berggren, a master's student in Security and Cloud Computing at Aalto University in Finland. Thank you for your attention.
All right, so while Maggie climbs up here, please pay extra attention to Maggie's talk today, because she was also the last speaker in the last Pepper session yesterday. So 2 days in a row being the last speaker of the day is kind of tough.
Yeah. Well, luckily, I come to you today with a strong belief that is very weakly held. But my agenda is that I would like us all to spend a lot less time thinking about, talking about, and researching the concept of trust in technology. So first of all, what I'm not talking about. I'm not talking about cryptographic trust. You guys can keep that metaphor. I like it. Not trust in a company, not trust in peer-to-peer services. I want to talk about specifically trust in technological artifacts, and trust as we often see it as a research construct that we tack on at the end of our surveys in HCI papers. And I'm talking at us, subtweet at the SOUPS community. We do this all the time. So here's my own home institution. Our homepage currently says creating trust emblazoned across the front. Here's a Facebook career page looking for trust in AI scientists. Here's IBM. They're really excited about building some trusted AI. And if you look at abstracts of academic papers that include the word trust, you'll often see this type of argument. If people don't trust this tech, they won't use it. But I want to back up here. Usually, the goal in our case is not to get users to use computing technology. Usually our end goal is actually something more like this: design and build desirable technology. And while we can argue for a long time about what our ethical conception of the good looks like, for the most part, for most of us, getting and convincing users to use a specific technology is not in our definition of the good in a core way. So trust is actually a side effect of desirable tech. It's the steam off the noodles. And when you eat, you're not trying to create steam, basically. So here's the summary of 3 other arguments about why trust in technology bugs me. So first of all, trust is an experience of the user, not a property of the artifact. So when people say that they're building for trust, what they're expressing is that they're trying to engineer a discrete feeling in the user, rather than building a good artifact itself. So if you are building a discrete feeling in the user, often you're actually a marketer, not an engineer. So that's why a large chunk of trust happens at management and marketing conferences and journals. Third, if there is in fact a piece of desirable tech that we've decided we really want people to use, then it becomes an adoption problem, not a trust problem. There are many reasons I use trust that I use tech that I don't trust, and there's many tech that I use that I do not trust. So focusing on adoption, not on trust, is what we should be doing there. And I don't think this is just misguided. I think in some cases it can actually be a little dangerous. So here's an example. Rhetoric is powerful, and I think specifically the rhetoric of trust, it's so connotatively laden, it teeters on the edge of being dangerous. So in 2018, there's a Scientific American article that concludes that, quote, the problem with Watson for oncology was that doctors simply didn't trust it, and that's why they didn't use it. And actually, a few months later, a bunch of documents are released from IBM that suggest actually the problem with Watson for oncology was that it wasn't a great tool, and we shouldn't have deployed it that fast. So just one totally cherry-picked illustration, of course, about why this is. So here's my hill to die on. Don't build for trust, please build with values. As researchers, don't measure trust. Measure exactly what it is you're actually trying to measure. So instead, if you are trying to use trust as a way to describe desirable tech, think about some other rhetorical framings that are more useful. Trustworthiness has a value judgment attached to it. Contextual integrity, value line design. If you want to actually think about this adoption problem, use those technology adoption models that we worked on for decades. If you want to think about user perception, think more carefully about what it is exactly you're trying to measure. Is it safety? Is it perceived risk? Is it something close to emotional valence? Use that carefully. And even if you don't believe me that trust is worth throwing away in most of our context, I hope you at least take away the idea that research is not just a scientific exercise, it is also always a rhetorical one, and the SOUPS community should think very carefully about the framings that we use. Thank you.
All right, thank you. Let's thank all our speakers again.